Welcome everyone. Through this video, today I will discuss the basic derivatives. You know, the basic derivative parts of mathematics is widely used in physics. It is most important for understanding the physics subject. So, basic derivatives. Number 1. Derivative with respect to x, d dx of x to the power n. So n into x to the power n minus 1, where n equals to constant. If n is constant, then n come forward and power will diminish by 1. So what is the restriction? N is constant and this x is algebraic function, linear algebraic function. So we are not going through the proof of the result. Proof is given by L'Hospital rule by my earlier videos. So I am discussing only the result. So application d dx of x to the power 1 by 3. 1 by 3 is constant. So 1 by 3 into x to the power minus 2 by 3. Now d dx of 1 by 3 is constant. So 1 by 3 is constant. So you can apply it. X. So power is 1. 1 into x to the power 0. That is x. d dx of x is 1. Now d dx of x to the power x. So x into x to the power x minus 1. This is wrong. Mind it. Why? Because this formula is applicable when power n is constant and this is linear function. Now, you know linear form of algebraic function is, this is general form ax plus b. This is linear form of algebraic function. So in general, so d by dx of x plus b whole to the power n equals to n into power diminished by 1 into, if it is linear, coefficient of x. Coefficient of x. Or you learn later, when you find derivative by chain rule, that is derivative of function, n come forward, power will be diminished by 1, then derivative of ax plus b. Derivative of ax is a and derivative of b is 0. But we remember it in this way. If it is linear and power is constant, n come forward, power diminished by 1 into coefficient of x. This is n a into ax plus b whole to the power n minus 1. So this must be linear. So application, you look d dx of 2 minus 3x whole to the power 4. So it is linear. So we can apply it. 4 come forward, 2 minus 3x whole to the power 3 into coefficient of x minus 3. So minus 12 into 2 minus 3x whole to the power 3. So this one is general. So this formula is applicable when this argument is linear algebraic function. Look, d by dx of x square plus 2 whole to the power 5. So 5 into x square plus 2 whole to the power 5 minus 1. This is not true. Here 5 is constant, but this one is not linear. So we can use this formula when this one is linear. So you can find derivative of this function. I will discuss later by chain rule. So basic derivatives, first result d dx of x to the power n into x to the power n minus 1. So see the restriction, n equals to constant. And in general, d dx of ax plus b whole to the power n equals to this. So you can use this formula when argument is linear and power is constant. Now, result 2. d dx of e to the power mx, d dx of e to the power mx. So e is base of logarithm, so its value is, I have already discussed, this is irrational number, e is irrational number, base of logarithm. So derivative of e to the power mx, e to the power mx into coefficient of x. So m into m. So here also same principle. If power of e is linear algebraic function, we can perform the derivative by this very rule. E to the power mx, e to the power mx into coefficient of x. Now application. d dx of, you look e to the power x. So e to the power x into coefficient of 1. So that is coefficient of x is 1. So derivative of e to the power x is e to the power x. So you remember, so this one is general. From this you can find derivative of e to the power x. But if you know d dx of e to the power x equals to e to the power x, you cannot find derivative of e to the power 2x, 3x and so on. So e to the power mx, e to the power mx into m. So look, d dx of e to the power minus x, e to the power minus x into coefficient of x into minus 1. Mind it. Now I have already discussed these basic derivatives are applicable when argument is linear function. So what is general formula? In general, d dx of e to the power a plus bx, e to the power a plus bx. A plus bx is linear algebraic. So e to the power a plus bx into b. You must remember these fundamental results. So e to the power a plus bx, e to the power a plus bx into b. So this is our general result. So look, for example, d dx of e to the power 2 plus 3x equals to e to the power 2 plus 3x. This is linear algebraic. Into, mind it, coefficient of x into 3. Into 3. So look, d dx of e to the power x square, e to the power x square, not possible because this one is not linear algebraic, not linear algebraic. This should be noted. All the 10 basic formulae are applicable when argument is linear algebraic function. Next, number 3. ddx of a to the power mx equals to a to the power mx into log a base e into coefficient of x into m. So you can write it m log a into a to the power mx. This should be noted. Most of the students write derivative of a to the power x is ddx of, some student write ddx of this x into a to the power x minus 1. This is wrong, because if n is constant and base is variable, then x to the power n is applicable. So this formula is not applicable. So look, ddx of a to the power mx. So if a equals to e, you get the second one. Look, you know log e is 1. So m into e to the power mx. So application, ddx of 2 to the power x. So 2 to the power x into log 2 into coefficient of x, this is 1. 2 to the power x into log 2. I have already discussed, mind it, in case of mathematics, log log, we consider base as e. ln, it is always e, but in mathematics, if it is log, we suppose base is e. Otherwise, base will be stated. Now, ddx of 2 to the power 5x. So look, base is constant, power is variable, then it is applicable. Base is constant, power is variable. So, a to the power mx into log 2 into coefficient of x, 5. Now, in general, ddx of a to the power mx plus b. Look, power, this one is algebraic, base is constant. So, what is our result? A to the power mx plus b unchanged into log a into coefficient of x. So, this is a to the power mx. So, you should remember the a to the power mx into log a into coefficient of x. It is general and it is also most general. Now, ddx of 2 to the power 3 minus 5x. So, base is constant, power is linear, algebraic. So, 2 to the power 3 minus 5x into log 2 into minus 5. Mind it, coefficient of x minus 5. So, ddx of a to the power mx. A to the power mx into log a into m. So, keep in mind. And number 4. d by dx of log x equals to 1 by x. 1 by x. We know domain of x is 0 to infinity. Log x is defined when it is 0 to infinity. Now, general result, ddx of log ax equals to 1 by ax into coefficient of x. Mind it. So, 1 by x. So, This to be noted. Log, obviously base is e. Log ax, what is derivative? Not 1 by ax, 1 by x. So log 2x, what is the derivative of log 2x? 1 by 2x. Some student write 1 by 2x, but it is not true. 1 by 2x into 2. So 1 by x. If it is log x by 2, then it is also 1 by x. How it is obtained? 1 by x by 2 into coefficient of x. So 1 by x. So this one. And in general, d dx of log x plus b base e 1 by x plus b into coefficient of x. If it is x plus constant, then it is not 1 by x plus b, 1 by x plus b into a. Now application. d dx of log 2 plus 3x. So this is linear algebraic. 2 plus 3x into 3. So not 1 by 2 plus 3x. So if it is linear algebraic, derivative is 1 by x into coefficient of x. And I am repeatedly saying, if argument is not linear, for example, log. So look, log of sin x, d dx of log of sin x. This is 1 by sin x. It is not possible because sin x is not linear. 1 by sin x. So you can find derivative by chain rule. I will discuss it in other videos. But look, d dx of log x square plus 2. So argument is not linear. So you cannot write log x square plus 2. I am saying repeatedly, this formula is applicable when argument is linear function. Now, d dx of log x is 1 by x when base is e. This to be noted. But if we find d dx of log x base is a, then this is 1 by x, not 1 by x. This one is not 1 by x. Because if it is base is e, then it is 1 by x. So this step to be noted. If it is not e, then we write it in this form. This is log x by log a with any base. Formula is log a base b equals to log a by log b with any base. So we can take it e. Now d dx 1 by log a is constant. So it is outside derivative. I will discuss it later. If it is constant, then it will be outside derivative. So 1 by log a base e into 1 by x. 1 by x. Or you can write it. So 1 by x into log e base a. So property of log, if it will be at the numerator, so base will be changed. By this property, log a base b 1 by log b base a. So if it at the numerator, base will be changed. So you remember it. This to be noted. So no need of showing the steps ddx of log x base 2. If it is 1 by x into log e base 2. If base is not e, it is 1 by x into log e, then what mention? Base is mentioned. Or you can write it 1 by log 2 into 1 by x. So they are equivalent because it is at the denominator, base will be changed. So finally you look d dx of, this is log 2, this is x cube. So this is not linear. So you cannot find derivative by this rule d dx of log a. But use formula of log. This is 3 log x base 2. 3 come forward by property of log. So 3 outside. Log x base 2, then d dx. So this is 1 by x into log e base 2. So what is our result? You have to remember this one. d dx of log x base a equals to 1 by x into log e base 2, or 1 by log 2 into log a. Sorry, this is log a. Log a into 1 by x. 1 by x. So if base is not e, you have to multiply by log e base a, if it is base is a. And we can perform derivative when this one is linear. This is not linear, but using property of log, you can make it linear. So these are the 4 basic result of derivative. So this formula is applicable when function is linear algebraic. So you should know the 4 basic results. In the next part of video, I will discuss 6 basic results of derivative. So thank you for today.